In this video, we're going to be talking about section 4.2, which is just going to further explore trigonometry. We're going to kind of revisit the unit circle and review some things from geometry. So first of all, you should be familiar with the statements, the phrases sine, cosine, and tangent. And so today we're going to review that. I've never been a big, learn by memorizing a phrase kind of a person, but a pretty common way for people to learn and keep in mind which one's which is the phrase SOHCAHTOA, which you can see at the top of the screen here, where sine goes with opposite over hypotenuse, and cosine goes with adjacent over hypotenuse, and tangent is opposite over adjacent. And so that, if you put all that together, gives the phrase SOHCAHTOA. Again, I'm not a huge fan of learning that way, but for some people, it could help. So sine, as we just said, is the opposite over hypotenuse. And cosine is the ratio of the adjacent side of the triangle. I guess I didn't really give the preamble to that. So this is just looking at ratios of the sides of the triangle, adjacent over hypotenuse. And then the tangent is when you look at the opposite side to the adjacent side. And what's going on here is that no matter the size of the triangle in terms of the angles, right? So we're talking about like similar triangles. If the sides stay at the same ratio, then the angles are exactly the same. So long story short, every angle of, say, 40 degrees will have the same ratio no matter if it's, centimeters large or, inches or feet large. The ratio of these sides will be the same. So what that allows us to do is, since the ratios are always the same for the same angles, if we know the ratio, we can find the angles, which is a good tool in finding unknowns. All right, so let's look at this in terms of this triangle. So let's think about from the perspective of angle A. So reference angle A. The sine of A, by the way, it's not sin, it is sine. Yes, we leave off the E, that's the abbreviation. It's not much of an abbreviation, but that is the sine of A is equal to the opposite. So in this case, that would be the side A over the hypotenuse, which would be C. And then cosine of A would be the adjacent side over the hypotenuse. And then the tangent of A, don't know why I capitalized that, I just did. Tangent of A would be the opposite side, the A, over the adjacent side, B. And, there are two non-right angles in a right triangle. So we could also look at it from the perspective of the other angle. So reference angle B, then the sine of B is the opposite from B, which would be little b, over C. The cosine of B is adjacent over hypotenuse, and the tangent of B is opposite B over A. All right, so we're going to be basically, spending time with sine, cosine, tangent today. So let's take a look at example one. Given the right triangle, evaluate each trig ratio. So in trigonometry, as we've discussed, when you have unknown angles, it's very common to use the Greek letters as the variables. So theta is your go-to variable. Alpha is a good second. We'll go to beta sometimes. Looking at the sine of alpha, well, in order to do that, we're going to need to know that third side. So along with our trig ratios, sine, cosine, and tangent, we also don't forget about our very good friend, the Pythagorean theorem. And so we know that 3 squared plus 4 squared equals the unknown c squared. Make sure you know that the hypotenuse is always the one that's the biggest. So regardless of what your unknown is, the setup is the same. It's got to be the legs squared added together to equal the hypotenuse squared. So, but also hopefully we are familiar enough with right triangles that we recognize the 3, 4, 5 right triangle. If not, then Pythagorean theorem, finishing this off, will tell us that it's 5. But there are some common right triangles we'll kind of encounter often, and so it'd be good when you start to recognize them. So C is going to equal the square root of 25, which of course is 5. All right, so that makes the sine of alpha 4/5. And the cosine of alpha would be 3/5. And the tangent would be 4/3. The sine of theta, so the sine of the other angle is 3/5. The cosine would be 4/5. And the tangent would be 3/4. All right, let's keep going. All right, so now let's think about our work with the unit circle, and let's think about how sine and cosine and tangent are related to that. So if we have just a random point on the unit circle, and again, a unit circle, the key thing is that means the radius is 1. And I look at this coordinate point, it would be the point x, y. Then if I make a right triangle out of this, as we've done many times, we know that this is going to be the x distance, this is the y distance, and then we know this is 1. And so if theta here is our central angle, then we know that the sine of theta is the opposite side, which is the y value, over the hypotenuse, which is 1. But if, and this is a key piece, if we're talking about a unit circle, the hypotenuse will always be 1. So if it's a unit circle, we can actually just simplify that down to say that if you're on a unit circle and you know the coordinate point of the terminal side, then we know that the ratio of sine is always just going to equal the y value, y over 1. And cosine is always going to equal the adjacent side, which is x over 1. So that is one of the advantages of learning the unit circle the way we taught it before we started this unit, is that we can simply find the sine and cosine and tangent of those angles by focusing not on the right triangle necessarily, but on the coordinate point. The tangent of theta would be the opposite side, which would be the y value, over the adjacent side, which is the x value. So tangent of theta is simply the y over the x. All right, it's time to introduce you to the 3 other trig functions, their other trig ratios, and that would be cosecant, secant, and cotangent. So this is cosecant, and this, of course, is secant. Cotangent. And these are just the reciprocals of sine, cosine, and tangent. So it is convenient at times to be able to compare the sides in the opposite way, but sine, you're not allowed to do that. Like sine is a very specific, you're looking at the opposite to the hypotenuse. So if you wanted to instead look at the hypotenuse and compare it to the opposite, you could do that, and that's what cosecant does. So cosecant does the hypotenuse over the opposite. So it's the exact reciprocal of what we just did for sine. So then in our case, the cosecant of theta would simply be flip over y, which would be 1 over y. And the secant of theta is simply the hypotenuse over the adjacent side, which is the reciprocal of cosine. So that'd be 1 over x. And then the cotangent is, of course, the reciprocal of tangent. So that's the adjacent side over the opposite side. So that would be x over y. Okay, so they're just simply the reciprocals. They're also known as the reciprocal trig functions, sine, cosine, tangent. Now, it would be great if the naming was such that sine went with secant, like S's go with S's and C's go with C's, but that is not how the naming works. So the way to remember this is the opposite letter. So sine goes with cosecant, and cosine goes with secant. So opposite letters match up if you need a little helpful hint. Okay, so let's use that knowledge and let's calculate some trig functions. So let's find the sine of 7 pi over 6. So 7 pi over 6, just, in case we need the reference, we're going to look at our unit circle. And we know that 6 pi over 6 is 1/2 of the circle. So we are simply a pi over 6 beyond that. So there's 7 pi over 6. And we know that this coordinate point, let's use our visual cues. The longer side is the x, so that's going to be your root 3 over 2. And your shorter side is the y value as 1/2. And both of those values are negatives. So now the sine of 7 pi over 6 is simply the y value, which is going to be negative root 3 over 2. Part B, the cosine of 3 pi over 4. Cosine and sine, or actually I should say more, 3 pi over 4 is easier because both coordinate points are root 2 over 2. So makes it easy. We already know the answer is root 2 over 2, but let's think about the positive and negative of it. 3 pi over 4 would be sitting right here. And this is going to be root 2 over 2, comma, root 2 over 2. But the x value is negative. Cosine is the x value. So we're looking for the adjacent side, the x value over 1, which is negative root 2 over 2. Sine of 2 pi, we know that 2 pi wraps all the way around the circle, and so we're sitting right here. And we know this is the point with an x value of 1 and a y value of 0. And so then the sine of 2 pi is simply the y value, which is 0. The tangent of 5 pi over 6. 5 pi over 6 is going to be a pi over 6 short of half a circle. So we know, once again, we've got the half here and negative root 3 over 2 here. And so that's the x and the y. Obviously, I didn't write it as a coordinate. So the tangent is the opposite side, which is 1/2 positive, divided by the x value, which is negative root 3 over 2. So we divide fractions by multiplying by the reciprocal. So I'm going to multiply by negative 2 over root 3, which the 2's cancel, giving me negative 1 over root 3, which we need to rationalize, which would be negative root 3 over 3. So sine, cosine, very simple to do off of the unit circle. Honestly, I find tangent doing it this way a little bit cumbersome. And oftentimes I might resort to just thinking about how I learned the triangles in geometry to do tangent. So for example, once I figure out that this is, a 30-degree angle we're talking about, then sometimes my brain will just go back to, hey, I originally remembered this as 1, 2, square root of 3, right? And so if I want the tangent of theta, I would do 1 over the square root of 3, which is what we have right here. So there are times when the unit circle super duper helpful, helps you get quick answers. But sometimes thinking about it as a right triangle and how we learned it in geometry makes it easy as well. Just remember, if your hypotenuse is not 1, then you can't just go with the x and the y value for sine and cosine, right? You have to. The only reason it simplifies down to just the y value or the x value is because your hypotenuse was 1. So just something to keep in mind. All right, let's keep going. So let's just expand upon that the that process. Evaluate all 6 trig functions for each of the given angles. So 11 pi over 6 is, I guess I'm sticking with a theme here. It's a pi over 6 shy of all the way around. So we are at positive root 3 over 2. And we are at negative 1/2. So whenever we're asked this question, I'm going to organize my work the same way to make it easy on myself. Sine of theta first, cosine of theta, tangent of theta. I'm going to find those answers. And then I'm going to find the reciprocals of those. So I'm going to make sure to align those correctly. So cosecant of theta, secant of theta, and cotangent of theta. All right, sine is the y value. So that's negative 1/2. Cosine is the x value. So that's root 3 over 2. Tangent of theta now is a little obnoxious because we've got these fractions I've got to divide, but it's going to be the opposite, the y value over the x value, or said another way, the sine over the cosine, right? If tangent is y over x and sine is y and cosine is x, then tangent is simply the sine divided by cosine. So I'll do that math down here. Negative 1/2 divided by, so I'm going to multiply by 2 over root 3, which gives you negative 1 over root 3. So we've got negative root 3 over 3. Cosecant, flip over sine, would just be 2 over 1, positive. Obviously, I do not need the over 1. Secant of theta becomes 2 over the square root of 3, which I need to rationalize, so we ought to be able to do that in our head. Would become 2 root 3 over 3. And here's where it's kind of obnoxious. So we took the time, we got this answer here that we rationalized to be there. Now, what did we do when we rationalized? We got our denominator to have no radicals, but we do have some in the numerator. Well, now I'm about to flip this thing over, so all that work I just did to put that radical in the numerator now becomes a problem when I say the answer is negative 3 over root 3. That's why, especially whenever doing this, I'll kind of keep this number in mind before I rationalized it, because then that'll save me a little bit of time so I don't have to re-rationalize this thing again. So in other words, I could just kind of flip over this answer, which is what tangent was before we rationalized it. Long story short, the answer is negative root 3. 2 pi, we just took a look at this one, right? This is the coordinate point 1, 0. So sine of theta, sine of 2 pi, is the y value. That's 0. The cosine is the x value. And tangent is the sine over the cosine, the y over the x. That's just 0. Cosecant is flip over the sine. So the sine was 0. If I take the reciprocal of 0, I get 0 in the denominator, and I cannot have a denominator of 0. So there actually is no ratio I can write that is the cosecant of 0. Or, I'm sorry, of 2 pi. Also 0. The reciprocal of 1, of course, is 1. So the secant of theta would still be 1. And the cotangent is the same issue. Reciprocal of that you cannot do. All right, let's keep rolling. Cosecant of pi over 4. So now I'm just kind of randomly throwing some at you. Pi over 4 is root 2 over 2 for sine and for cosine, for x and for y. So what's the best way to think about this problem? If you're going to think unit circle, then we know we're talking about, again, the root 2 over 2's. You do all this in your head. So once you get that figured out, Cosecant is the reciprocal of sine. Sine is the y value. So this is going to be the reciprocal of 2 over root 2. So once again, this is a little obnoxious because 2 over root 2 needs to now be rationalized. And so I'm going to multiply by root 2 over root 2, which gives me 2 root 2 over 2, or just root 2. So honestly, again, the unit circle, very helpful. But at times, this problem like itself would have been easier if I've just got my pi over 4 45-degree triangle and think about it as 1 square root of 2. So then if I'm asking you for the cosine of 45 degrees, then the cosecant, it'd be the hypotenuse over 1. And that would be my answer. So don't be locked in on only be able to think about the unit circle. Be able to, pick and choose a tool that's going to work best for you. Cotangent of 3 pi over 2. I'm going to visualize where that is. 3 pi over 2 is right here. And that is 0, -1. Tangent is the y over the x. So cotangent is the x over the y. That would be 0. Secant of 2 pi over 3, if you're going to think unit circle, find it. It's right here. So that's going to be, the x value is going to be -1/2 and root 3 over 2. Secant is the reciprocal of cosine. The cosine is the x value. So this is the reciprocal of -1/2, -2. 9 pi over 4, I know, is a version of 45-degree angle, and I know that both of the legs on a 45-degree angle are the same, either because I'm thinking about it as a triangle, 1 and 1, or I'm thinking of it on the unit circle, root 2 over 2 and root 2 over 2. Either way, the tangent is going to be 1. Now, is it positive or -1? That depends. 9 pi over 4 is where? 9 pi over 4 is coterminal to pi over 4. Because 8 pi over 4 gets me all the way around, and then 1 more pi over 4 is 9. So I know that both of the values, again, are root 2 over 2. And so the answer is going to be 1. And the cosine of 840 degrees. I have no idea what is coterminal to 840 degrees. But obviously, it's more than one circle. In fact, it's probably more than 2 circles. So to figure out what circle I'm talking about, I guess I'll subtract 360, kind of figure out what angle that's going to be. So that's going to be 480. Checking my math on that. 8 plus 6 is 14. Carry the 1. Yep. Which is still bigger than the circle. So I'm going to take away another circle. 8 minus 6 is 2. This is 120-degree angle is what we're talking about here. So the cosine of 840 is going to be the same answer as the cosine of 120. And 120 is 2 pi over 3. We just drew that picture over here. So if I want the cosine, and then it is simply -1/2. All right, the last thing we're going to talk about today is making sure we know how to use our calculator. So using your calculator to find the sine, cosine, and tangent, we're only going to do that if the ratios are unknown to us, right? So any of your pi over 3s and pi over 4s and that stuff, we're not going to mess with the calculator. But pi over 13, I don't know what that is, right? So, and even if I convert that to degrees, it's not going to be one of my known sides. So we need to be comfortable with our calculator. So the first thing I need you to know is that your calculator needs to know what mode you're in, because the cosine of 1 radian is going to be a much different answer than the cosine of 1 degree. So this is a question, sine of 6 pi over 13. There's no degree symbol, so we're in radians. So I've got my calculator over here. So we're going to want to make sure, and your calculator may like give you some information on the screen. If it does, you're looking for the word DEG or RAD, which will tell you which mode you're in. But on this TI version, I'm going to hit the mode button, and then you'll see on the third line, we've got radians and degrees. Radians is the default. It is the number one choice. And so I am already in radians, just coincidentally. So I'll quit out of that. And now I just need to put that into my calculator. So I'm going to take and I'll figure out what the sine of 6 times pi, and I think you don't need to do the times. It's already built in. 6 pi over 13. And this is approximately, and we're going to make sure we use approximately whenever we're not giving an exact answer. And we'll go to 3 decimal places unless it specifies otherwise. All right, so 6 pi over 13 is 0.993. That's very close to 1. Let's think about that for a minute. 6 pi over 13, if it was 90 degrees, it'd be what, 6.5 pi over 13? So yeah, we're looking at an angle that's going to be very close to 90 degrees. And so that would mean that the y value should be very close to the same y value at pi over 2, which would be 1. All right, 8.1, that is in radians because there's no degree symbol. So if I want to do the cotangent, I need to really think about this because my buttons on my calculator are only sine, cosine, and tangent. So what I'm going to end up doing is I'm going to instead find 1 over the tangent of 8.1. Because whatever the tangent of 8.1 is, remember we take the reciprocal of it, and then we will get our answer. So I'm going to go ahead and do this the wrong way. I'm going to do the tangent first of 8.1. This is not the right answer, but it is the reciprocal of the right answer. So then all I need to do is flip it over. And once again, this button on your calculator here, x to the negative 1. On some calculators, it might be, no, I think it's pretty standard actually. Well, actually, it might be 1 over x. You might see that button as well. So x to the negative 1 button will flip over, and I get an answer of approximately equal to negative 0.251. And then we have to notice the next question is in degrees. So it's easy to switch. Second mode, I'm sorry, just mode. And then down to degrees. And now we'll take the secant. Okay, so hold on, we can't do secant. But what we can do is the cosine. So I'm going to do 1 over the cosine of 127 degrees. So I'm going to do cosine of 127, giving me the wrong answer, and I'm going to flip it over. So I get an answer of approximately equal to negative 1.662. All right, that concludes our work in 4.2. You got lots of practice to do here. Let me know if you have any questions.